Now we shall see the C aromatic arenes, that is toluene. Now the physical properties of toluene. Toluene is a colorless liquid. Its boiling point is 110.6 degrees Celsius. Its odor is just similar to that of benzene. Toluene is insoluble in water, but it is highly soluble in alcohol, ether, and benzene. It is a good solvent for many organic substances. Now, this is the structure of toluene. We know that this is a arene part, benzene ring. This is arene part, and this is the upper part is of methyl group. We have seen that activating group and deactivating group. This methyl group is an activating group, and it is a orthopara directing group. That means it directs the incoming electrophile towards ortho position or towards para position. First we will see the preparation of toluene. Toluene, it is the simplest arene with side chain. Side chain means this part of methyl group, that is a side chain of benzene. So that is called as side chain. So it is the simplest arene with side chain. We can prepare it by Friedel-Crafts alkylation of benzene. आता हे फ्रिडल-क्राफ्ट अल्किलेशन काय आहे? समजा बेन्झीन किंवा अरीन रिंग आहे, ॲरोमॅटिक रिंग आहे, त्याला समजा अल्काइल ग्रुप आपल्याला लावायचा असेल तर लावायचा आहे, तर त्याला म्हणतो आपण अल्कायलेशन. तर अल्कायलेशन कशाच करत आहे? बेन्झीनचं करायचं आहे आपल्याला. तर इन दिस फ्रिडल-क्राफ्ट अल्कायलेशन दिस बेन्झीन इज ट्रीटेड विथ मिथिल क्लोराइड. नाउ दिस इज द मिथिल क्लोराइड. मिथिल क्लोराइड मध्ये मिथिल पार्ट जो आहे तो अल्काइल पार्ट आहे. दिस पार्ट वी हॅव टू अटॅच टू द benzene ring. So this can be done with the help of catalyst anhydrous AlCl3. It is a Lewis acid. We all know that AlCl3 is a Lewis acid. So in Friedel-Crafts reaction, the catalyst is used is anhydrous AlCl3. So the benzene, when it is treated with methyl chloride in the presence of anhydrous AlCl3, this methyl group will get attached to the aromatic ring and we get a toluene and HCl. Another method of preparation is root splitting reaction. So here the mixture of bromobenzene, that is aryl halide, and methyl bromide. Methyl bromide means alkyl bromide. It is a aryl bromide. Bromobenzene means aryl bromide, and methyl bromide means alkyl bromide. This mixture is treated with sodium metal in the presence of dry ether. This sodium carry out both the bromine from arene and alkyl group, and this alkyl group gets attached to the benzene ring and we get a toluene. So this reaction is carried out in presence of dry ether. Now third one is Grignard reagent. We know that what is Grignard reagent? It is the alkyl or aryl magnesium halide. So to prepare toluene, we will take phenyl magnesium bromide. This is a phenyl magnesium bromide. When this phenyl magnesium bromide is treated with alkyl halide, alkyl halide means CH3X, or it is methyl halide. Alkyl halide means alkyl group is methyl group, therefore it is called as methyl halide. In the presence of dry ether, this is the condition for Grignard reaction. In presence of dry ether, it gives toluene. So here the MgBr it will leave the benzene ring, and instead of that CH3 group will attach. This Mg, the second valency of Mg will be satisfied by this halo group, X group. Okay, therefore we get a MgBrX. Now if there were a Br, that means methyl Br, then we shall get magnesium dibromide here. Then the next method is from heptane by aromatization. Now here we take a heptane, that means the alkane with 7 carbon atoms. When this is treated with aluminum oxide and chromium oxide at high temperature and at high pressure, this undergoes aromatization. Aromatization means cyclization with dehydration, with dehydrogenation. Means in this there will be a cyclization, and there at the same time there will be a dehydrogenation. That means hydrogen atoms will be released, and it forms a toluene. Now since in this toluene there are 7 carbon atoms, and in heptane there are also 7 carbon atoms, that means the number of carbon atoms remains same, only hydrogens um, are left in the product. Okay. Then next method of preparation of toluene is reduction of cresol with zinc dust. Now whenever you want to remove the oxygen from phenol, then you have to always use zinc dust. Okay. Now here metacresol is taken, but you instead of metacresol you can take orthocresol or paracresol. That means either ortho, meta or paracresol. Orthocresol means if the OH group is present at ortho position, then that will be called as orthocresol. If it is present at meta position, then it is called as metacresol, and if it is present at para position, then it is called as paracresol. Here we have taken metacresol. When this metacresol is heated with zinc dust, the oxygen atom will be removed. Okay, that means reduction will be reduction takes place, and therefore we get a toluene. So these are the 5 methods of preparation of toluene. Which are the 5 methods of preparation? First was we have considered that Friedel-Crafts alkylation. In this, benzene is treated with alkyl halide in presence of anhydrous Al to get a toluene. Second method was root splitting reaction, in which bromobenzene is treated with methyl bromide in presence of sodium and dry ether to get a toluene. Third method of preparation was from Grignard reagent. We have taken phenyl magnesium bromide that was treated with methyl halide or methyl bromide or alkyl halide in the presence of a dry ether. Alkyl halide means methyl halide, because we have to prepare toluene. That means we have to attach CS3 group only. Okay. Therefore, we have to take methyl halide in presence of dry ether. We get a toluene. Then from orthocresol or metacresol or paracresol, here we have taken orthocresol. When this cresol, ortho, meta or para, it is heated with zinc dust, then oxygen will be removed and we get a toluene, or reduction takes place and we get a toluene. Then the last method, that is fifth method, is from N-heptane. There are this is the alkane with a 7 carbon atom. Here the cyclization and aromatization, that means dehydrogenation takes place to get a toluene. Now let us see what are the chemical reactions of toluene. First part, electrophilic substitution reaction on benzene ring. Now we know that methyl group is a activity group and it is electron orthopara directive group. Okay, so it directs the incoming electron. What is meant by electrophile? Electrophile means a species with a positive charge. Okay, it directs that incoming electrophile towards ortho and para position. First we shall see the halogenation. So halogenation means the reaction of toluene with chlorine or bromine. Here we have taken chlorine. So the reaction of toluene with chlorine in presence of FeCl3. If we take here Br2, then we have to take here FeBr3. Okay, this halogenation, this chlorine will attach at ortho position and para position. Therefore, we get a product at orthochlorotoluene and parachlorotoluene. Okay, instead of chlorine, we can take a bromine also. Here, the catalyst is a ferric chloride or ferric bromide, and this reaction is carried out in the absence of sunlight and low temperature. You have to keep it in mind that this reaction always takes place in absence of sunlight, because in presence of sunlight some different reaction takes place. Okay, so in this case the electrophile is Cl plus. This Cl plus is electrophile. It attach either to ortho position or to para position. Therefore we get a ortho and para products. Next is nitration. We know that the nitrating mixture is concentrated H2SO4 and concentrated nitric acid, that is HNO3. Due to this reaction between this concentrated H2SO4 and nitric acid, we get an electrophile as NO2 plus. Now here in nitration, NO2 plus is an electrophile. Therefore when toluene undergoes nitration, it will give orthonitrotoluene and paranitrotoluene. That means this nitro group will attach, this is electrophile, will attach at ortho position and at para position. Now on prolonged heating, if we keep the heating continues with nitrating mixture, that is concentrated H2SO4 and concentrated HNO3, it gives 2,4,6 trinitrotoluene. Remember, you can see here that the nitro group is attached to the ortho position and para position only. Meta position remains as it is. Therefore, we get a product as 2,4,6 trinitrotoluene. Okay. Then sulfonation. Toluene gives a mixture of ortho and para products with fuming sulfuric acid. Now sulfonation is carried out in presence of fuming sulfuric acid. So when the toluene is treated with fuming sulfuric acid, we get orthotoluene sulfonic acid and paratoluene sulfonic acid. In this case, SO3 plus, it is the electrophile. Therefore, it is attached at ortho position. This is toluene, this is methyl group. The position just the position um, just on the right side or left side of the methyl group is ortho position. So it is ortho position, SO3H is attached, and here the in second product there is a para position because it is exactly opposite to the methyl group. Okay, this is para position, this is ortho position. So we get orthotoluene sulfonic acid and paratoluene sulfonic acid. Friedel-Crafts alkylation. We have seen earlier that the Friedel-Crafts, what is Friedel-Crafts alkylation? It is the reaction of aromatic ring with alkyl halide so that the alkyl group is attached on the benzene ring. So in the presence of, and the reaction is always carried out in the presence of anhydrous AlCl3. Therefore alkyl halide is here, we have taken alkyl halide as CS3Cl. Therefore this alkyl group is CS3. So there is ortho product and para product. Now here ortho product is obtained in a minor amount due to the steric hindrance. आपण आधीच पाहिला आहे स्टेरिक हिंड्रन्स म्हणजे काय. ऑर्थो पोझिशन ही मिथिल ग्रुप, आधीचा जो मिथिल ग्रुप होता त्याच्या जवळ असल्यामुळे ऑर्थो पोझिशन, दुसरा जर मोठा ग्रुप असेल किंवा त्याच्या एवढाच जर ग्रुप असेल तर तो त्याला येण्याला विरोध करतो, अडथळा निर्माण करतो. अडथळा निर्माण करतो म्हणजेच हा प्रोडक्ट कमी तयार होतो, मायनर प्रोडक्ट तयार होतो. आता पॅरामध्ये ही पोझिशन, पॅरा पोझिशन दूर आहे CS3 पेक्षा, म्हणून अडथळा काही होणार नाही किंवा स्टेरिक हिंड्रन्स तिथे होणार नाही. त्यामुळे तो प्रोडक्ट जो आहे सेकंड प्रोडक्ट, दॅट इज पॅरा प्रोडक्ट, will be in a major amount. Okay, because bulky group is far apart from the methyl group. Okay, therefore this product, para product, is obtained in major amount and ortho product is obtained in minor amount. Okay, now Friedel-Crafts acylation. Just like alkylation, there is a acylation reaction. What is acylation reaction? In acylation we treat the toluene with acyl group. Acyl, which is the acyl group? RC double bond O. This group is a acyl group. Here we take a acetyl chloride. Okay, here there is acyl group, acetyl group. Acetyl group, it is the acyl group. Acyl is the general name, acetyl is CS3. When we attach, when we take R CS3 instead of R, then it becomes acetyl. So it is a acetyl chloride. Okay, so which is the acetyl group? CS3C double bond O. It is a acetyl group and it is a chloride. So the same thing, that is this reaction is carried out in presence of catalyst anhydrous AlCl3. Here we can use the solvent CS2, that is calcium carbon sulfide CS2. It is a solvent. So when this toluene is treated